Hello and welcome back to another episode of GiG-07. Welcome back, Sydney.
Hi.
Getting into GiG-07 is the show's name, but it's all about GiG-07, so it wasn't too far off. In the last episode, we created this new fantastic commit object, which is a high-level commit that is bound to the handle, so you can do all kinds of nice things with it. We added a few top-level methods. Also, after looking at Git2 to figure out how we should expose this, like what kind of level of detail would you want, knowing that whenever you call a top-level function, you kind of need to decode the whole object, so that might be inefficient, but we decided it's probably a good idea to allow people to have the convenient way, and the others, they might just use decode and then use the underlying object multiple times, something like that. But today, before we move on with anything more exciting, we have to finish this so that the to-dos go away. Tests might be the most interesting. That said, what would you write here?
Oh, for the documentation. Yeah, I mean, this gets the message ref, so it kind of parses the message itself again, right? So maybe something like
after decoding into a message ref, after decoding the entire commit object. Yeah, something like that. That's pretty cool, by the way. So you see, I already used markdown syntax here. And now link this up. And now you can just jump to the documentation directly.
That is pretty cool.
A bit cumbersome here to use the whole path, maybe. Yeah, I do like to use fully qualified paths, though, then it's kind of more obvious where this comes from. Yeah, it's interesting, really, because it adds kind of some clutter to your code, yet I prefer it or like it, because then if it's this, I always kind of think, could it be an easy commit message ref? So that's just, a lot of stuff here is ambiguous if you're on this abstraction level, one level up, and then you repeat names by necessity.
Of course.
Or you're really good in inventing new names that are actually good at describing what they're supposed to describe. Maybe that's better, don't know. Okay. And that's that. Okay, then let's look right at the test.
So for the test, I have a question really quickly. I mean, because both of these messages use the internal decode method, right? And I'm guessing that you already have tests for this message method. Does it then make sense to write tests for those two message and message raw functions here?
We added these. I mean, the whole commit object is new. So is this what you mean? Like there are no tests for the entire commit object yet?
Yeah, but my question is, would it be enough to only write a test for the decode function? Because the other ones are basically using this, essentially just kind of making it efficient. I don't know what's the strategy here, if you just want to have a test for every single function in general.
Yeah, I tend to be practical about this, so it's a great question to have. And simplification is good. Since it's really easy to test, I'll probably just call each of these once and just see if you get the expected result, to avoid something like this to happen just out of, I don't know. That's the only thing. That's that, but only once. And everything else is properly tested here, so the plumbing is always very well tested. So you would not, you can take it easier on the tests that you are doing on this level here. Also tree, I think, doesn't have a test yet. Which brings us to test. Where do we find tests? So there's the test subdirectory. Yeah, there's two kinds of tests in Rust, right? There's these tests that are in the test subdirectory. These are integration tests, technically, because they don't have, they do import the crate under test like any other client code would. So they see exactly the API as anybody else would when they use your crate.
So only public functions and structs and everything.
Yes, which also means you can only test public things. So if you want to test like these little private functions that you drop somewhere to do certain specialized things, then you have to put down a test here somewhere, and then you can test private things as well. If you're on the right module, of course. So even here, you can't test private things of sibling modules, for instance. You can only test private things of your parent module. Yeah, standard Rust privacy rules, so to say. But for this, of course, we want to try the public API. So yeah, usually you just follow the structure. So here we are, source, easy, object, and then let's quickly create an inline module for this. So now we have this file here. I really like to do this even if there isn't too much, just to keep this a bit lighter here, the top level, which is already, you know, relatively full here. And to have this structure more easily to follow, because the file structure, because I really use it to organize or to understand what's where. And if there's these inline modules, then you don't see it show up here, and then you might be thinking, is there no commit? Yes, there is, but you don't see it here. So that's kind of my broad rule of thumb. But you also see that I generally start with an inline module here, but then in one of the next steps, I refactor this and factor this out into its own file, which is so easy with IntelliJ. So the whole refactoring story in IntelliJ is really, really one of the strengths for sure. And a huge selling point. So I should be able to follow that structure, easy, object. So here you see it's not a directory yet, because there isn't really much going on here. So there isn't really tests for the object at all, which is also something you see a lot in Git repository. It's a bit under tested right now. My rationalization for this is that I am not so sure, or wasn't very sure about the structure in general and whether it would stay that way and whether I refactor crazily. So I just got things done quickly and have programs to actually run on this. So Cargo Smart Release, for instance, uses Git repository. So these are kind of my high-level integration tests, but of course, they're not really, they can't replace unit tests actually. But of course, the more stable things seem to get and the better that it falls into place, I think the safer it is to put down a few tests. Even though now we just do it, we do it a bit for practice because it's kind of so trivial, but also that's a good practice. So now, actually not like this, just mod commit. So I now follow the structure. We are in test easy object. So I would expect a commit module underneath to contain the commit tests.
That is just for your organization, right? That doesn't actually have to be that way for the tests.
Yes, this is just so that this matches one-on-one. You kind of know where to look for the tests. Of course, there are other ways to find tests by breaking things, and then the test should break. But generally, if you don't do that, then you should be able to follow the structure here, at least to some point. Okay, TFN. And it's interesting, you know, because, we'll see. So what now? Decode and message. Decode. Let's call it decode because we will call the decode function of the commit. Now we just need a commit real quick, which probably means that we want to reuse something that should already be there somewhere. Because somewhere here, I'd expect us to be able to get a repository or a handle even. Okay, basic repo. So basic repo gives us some basic repo, not further specified, that it does have some objects. And from there, we should be able to get some commit, for example, and do something with that. So we would use a real repository with real things inside. So it's kind of high level. So basic repo it is. Let's call that. Handle via basic repo. I think that's directly giving me a result here. Okay. So unwrap. You also see that most of these tests, they panic. So just unwrap everything or set the expectation here with expect. But in this case, unwrap is fine because that's not really under test here. But that's the first step. So once the test is working, I usually change it to use a create result, which is just a cheap type def for some error. And then I just replace everything with question marks so that this looks better. Usually that makes a difference just for clarity. I don't like these unwraps everywhere. So most tests that you find, they should not use unwrap for that reason. But it's easier to write the test without question mark, actually. So just by unwrapping things, because then you see where things fail with the line number. If it's question mark, you just see, oh, the test failed. And you see the debug error, but that sometimes isn't that clear. So this is why it's this two-step process for me. I hope it makes sense. And now we should be able to get the head, unwrap, right into fully peeled ID, expect born. Actually, yeah, here I do have to do expect. And then there, oh wait, what's this? That's the result. Okay. And then we should have an object ID. And now we get the object. And that is a commit, supposedly, and that will panic if it's not a commit. And that's easy, right? It doesn't like it. Maybe because a semicolon is missing. Okay. And that's our commit that we can work with. And it's interesting because it's forced us to use our API here. And one could say that, wouldn't it be nice if we could just kind of do into commit or something right here? Something like that. So as to cut all of this or cut that chain down a little. But yeah.
Yeah.
Maybe it's fair to kind of understand this first. And is there any question for you or any kind of anything you think about this, except for it's kind of a long chain?
It's really only the fully peeled ID. I'm not 100% sure what that does, what that means, but I think the rest is pretty clear.
Let's talk about this for a moment. Peeled. Yes, into fully peeled ID. So a reference, a head is a symbolic reference, which can point to an unborn branch, then you can't do anything. So this is why this is an option here, an option result, because if it's unborn, then there's nothing to do really. Which might also be something to think about. Do you want this to be an option result or should this just be part of the result, right? So this does not hide that it could be unborn. Even though in actual usage, you might just want a question mark out of this without having to deal with the unbornness yourself. So this might really be worth thinking about changing. Or having something that is more convenient, because otherwise I see people expect on this must be born, then programs panic, or or doing an okay or else just to uplift this thing to their own kind of error in case it's unborn. But why is this not part of the error that is returned there? Then you have an, you know, blah, blah, blah. Now you can do this, and then, you know, API design. Not easy, but it's easier when you have an actual example. So look, I also did it the other way around. So expect born is here, and then the unwrap is here. So should be born, and there should be no error in retrieving this. So now, what's the fully peeled ID? Head points to a reference, so it's symbolic. Then the reference can point to any kind of object. So it usually points to a commit, but it can also point to a tag object. And that tag object then has an object that it points to itself, which can also be a tag object. So you see, it has to follow the chain, which can be symbolic references, and then it can be objects that point to each other until you get something that is an end of chain. And end of chain is literally anything that isn't a tag object. So at the commit, you would stop, but you can also point the tag object to anything. You can point it to a tree. So this might not actually be a commit here, right? It commonly is. Otherwise, it's probably something weird that you don't want to actually deal with. But yeah, this is why it's so complicated, because it's so flexible.
A lot of different layers, yeah. Okay, yes. So the peeling just refers to peeling of the layers of the tags and just getting to the thing that's in the middle.
Yes. Phew. But yeah, this is definitely something to think about. I think something like this should be here as well, no? Head into fully peeled ID. See, so here we do the same thing, you know, the double question mark thing, but we define our own error, which doesn't seem to be a bad thing here. So yeah. And then ancestors you can actually call directly on object ID, which is practical, even though it requires a commit, I think, to actually work. So yeah, this doesn't look too bad here. But in our test right now, it looks really bad because of the expect unwrap stuff. But it's okay.
Yeah, you wouldn't need it, true.
And now finally, we should be in a spot where we can do an actual assertion. So the head commit. So I'd say if I decode this, yeah, in a way, I'm just testing the code now. Message should be commit message raw, right? And then we have these two already tested. Let's run this test repository. Oh, I'm also currently building things on nightly here. So all these warnings should go away. Wait, can't compare what? Oh yeah, this can't fail. Okay, fair enough. Now compile it again with nightly. And here's the test results. Speaking of, let's dock this. Every time. Okay. So I'm moving around some Zoom windows here. Okay. Okay. Test results all clear. Let's see if you find the one that we've just created. Commit. Object commit decode. Okay.
Seems to have passed.
Works. Now we can do exactly the same thing with message, and then this is message. Let's see if this can be compared even. Oh, nice, it can be compared because it's a custom type. Yeah, but I usually set the standard derive so that you can do the typical things with these types. Okay. And that's already it. That's the test for everything. So at least for these, that's done. Now for the docs, the hardest part. Oh, actually, no. First clean this up, huh? So that's it.
Getting rid of the unwraps.
Yeah. Get rid of these. Unwrap becomes question mark. And that's a bit better. Should still work. Oh, fails. Oh, yeah, right. Fails because now, and it's one of the disadvantages too, that now we have to be explicit here. Okay. That can also go down there. Probably that should not be pinned, whatever that means. Okay. And it works. All good.
Nice.
And doesn't look too bad, and that seems easy enough. So writing a test first also seems easy enough, but we did it with our program that we ran, so it's kind of the same workflow. But ultimately, once it stabilizes, it needs a test, no matter how small. Yeah, but definitely, I can imagine that we do this a lot here for commit-related tests, and of course, you can put this into a little helper, head commit. Voila. Where did I put it? Here. So probably that's already pretty much it. And now this is reusable. Then we don't care so much that this is what it is, even though we can still consider shortening the chain here. But yeah, something people want a lot, I think, getting the first commit. Okay, now I'm curious. What does Git2? What would Git2 do here? Git2, what do you do? Head, do you know heads? You do. Head, then you get the head reference that this points to, which might be unborn, then you probably get an error, because then there is no reference. So you see already Git2 doesn't really expose the unbornness here. Wait, what happened? Born. Unborn is unborn there. Only unborn is there. What else is there with head? Yeah, I thought there is a way to figure out if this head is born or unborn. Or is, yeah. But wouldn't know right now by just looking at this. Okay, interesting. So GiG-07 does it differently. This API is a bit simpler here, because then we would get the reference, and then from there we can peel to commit, and that gives us the next commit. Interestingly, there is something like that as well. We can convert this into the reference, and then we still, I mean, there's still nothing that peels directly to commit. So we always have to do this extra step with into commit or something like that, which I thought is fair, but yeah. So you see, Git2.
Yeah, is there ever a reason that you'd want to get the ID directly instead of the specific object?
Yeah, that's right. I mean, definitely. Probably not, unless you know, this is, I'm telling you, these things here, I'm pretty sure they were added because of that. So you are muted? Okay.
No, yeah, exactly.
Yeah. So they probably had it like this, so that you have to go through the steps, which makes sense. They are there for a reason. They're logical. But you don't have to know about it, right? So into, how do they call it? Oh, into fully peeled, or into commit, you could even say, or peel to commit. And then this would be the new chain. And you don't care about unbornness, it would just fail if it's unborn, like GiG-2 does. And I think this makes sense, so easier. Huh? So for now we can't do this, but to do, let's put that here at least. Add something like peel to commit to cut the chain, deal with unborn as result. To cut that option away here. And then this is kind of the low-level API that you can use if you want to, but you can also just cut to the chase more quickly. Okay.
I mean, you can still always embed this born and unborn stuff into the result when so the error, right? I mean, that's not going away.
Yes, that's true. It's just that reacting to this unbornness, it's a bit harder if you have to match on a potentially big error type. It might be okay though. I mean, have to look at the error type. Maybe it's worth it to just say, if you want to know unbornness or not, use this utility function here that we provide for convenience, or just match on the error. So the option is kind of something that forces you to think of unbornness when you write the code, which I like. This is why it's there. So you can't just miss this and then your program just errors out, even though it's kind of a natural state, because as a programmer, you don't think of that as a possibility. But if you would, maybe your program could be better. So maybe it's okay to just let people get there themselves instead of forcing them to think of every detail right away. So for the docs, parse the commits, decode the entire commit object in full and return the raw message bytes. Maybe that.
Yeah, I think making that reference to decoding the entire object is cool, because yeah, I mean, you noticed that there's probably a more efficient way to do this.
Yeah, maybe refer to that, but maybe not. I don't know. I feel lazy now. So let's just write the code here. Decode the entire commit object and return it for accessing all commit information. Note that this object is not bound to. Yeah, how do you say that? Is low level, maybe?
You mean you want trying to express that it's more efficient than the others, or
that you can't get back to the easy handle? Like you have this easy handle here that gives you easy access to all of the like high level access, but here you don't have that anymore. You just have low level access to actual commit IDs. And if you want to query one, you have to find the object yourself. It's not that this object doesn't make object lookup easy. But should be used for successive calls to string-ish information or something like that. To avoid decoding the object multiple times.
Yeah.
Or unnecessarily. Okay, like that. Good enough, I'd say. But if you have anything glaring, please always chime in.
Looks good to me.
All right, then for the last one. Oh yeah, this needs a test. Parse the commit and return the tree it points to. And maybe we can add the sibling here. I remember from yesterday, there's also tree ID here. And the tree ID. Could be just an option, so we degenerate the error here. Because there should always be a tree ID in a commit. There's no, and otherwise, yeah, just assume that something went wrong, like here. Oh. Get hash object ID. I think now it matches. Yes. This is just for completeness here. Tree ID and tree object maybe as differentiator. And then we can probably also call self tree ID here and cut that a little shorter. And how does that look like? If I do this, self handle find, nah, before that looked better, like that. Yeah, that looks better. Handle find, less cluttered. Try into tree. Yeah, that looks good. Okay, so now for the tests. Let's assume we will write them. So now this is easier. TFN tree, everything around trees, I guess. And head commit tree. So I just call this thing. And then we assume this can assert, you know, this is a cheap and dirty kind of things, right? So if you're not careful, you might actually get it wrong. So let's say that this ID, oh yeah, right, this can error, that this ID should equal I actually want to keep that. Commit tree. Something like that. Okay, so now at least this should be consistent in case we got that wrong. And then
is
what?
That actually testing anything? I mean, tree is using tree ID, so this would always be the same, right?
Yes, but we don't know that. It's more like it should be consistent, but now we have to be a bit more specific. Yeah? This is why I say it's okay to be lazy, but at some point there must be some substance. Which is, what do we know about that tree? At least the first entry we should know about, but asking for entries isn't easy yet. So I guess the tree ID should be some hex to ID. And then I always look for some idea I can paste here, knowing that it's probably not the right one. Hey, okay, I messed this one up. Like this. By the way, we never saw this message, this thing fail here. So probably this is also something we want to add here, that we have some more substance and maybe at least one failure. So what about the message being actually foobar? Okay. Oh, right. Haha. Yeah, that was the refactoring that I did there on a whim. But that doesn't work because the handle is the owner of everything. Remember, it has the buffers. No, it doesn't have the buffers, but it is something that is referred to by the commit. So we can't actually
just drop it.
Yeah, we can't do that. We have if you wanted to return the commit and the handle that is the referee, then we have a self-referential struct again, or a self-referential tuple in this case. So we can't actually do that. Yeah, so all you can do is something like this. You have to own the handle, and then you can shorten this part and do this so you don't repeat that all the time. So that's done. So 2 lines for the setup are needed here. Like this. Okay. Do I use this at all? No, I don't. Okay. Now 2 tests should fail if they compile. But that can fail. Yeah, okay, that refactoring didn't work. Great result. So you see, that's a nifty little type definition. We say we want a result and the default for T is unit. But you can also overwrite that. And that's neat. This is why that should work. If we do this. I wish IntelliJ would find a way to not paint everything red just because the return value is wrong. Just like, whoa! The end of the world. Yeah, not so bad after all. Okay, and now we start with unwrap. Method not found in std result. What? Commit. Oh yeah, right. So maybe that's not how this wants to be used. Maybe you just do the unwrapping. So that you don't have to deal with this a second time. Okay. Getting there. And now comparison. That's also, I don't know if you saw this, you might have seen this in learning Rust with GiG-07, that this by default is an array of 6 bytes. It's a binary string.
Actually, we saw that, yeah.
And now you have to, if you wanted it to be a slice, you could use some slice syntax or call a function on it. But the cool thing is that bstring actually compares naturally to a normal string. So you don't have to do that because this is a string slice by default. So it's exactly what you kind of would expect. It's a slice and not an array. Okay, let's hide the failing ones. Good. So that fails because our expectation is clearly wrong. So now we pin the tree ID down and say this is good. And here we have C2N as message. And now we've seen it red, and now it's green, and there's some substance to the actual test. Yeah, okay. And that shall be good enough for Git repository tests. I hope there will be no angry comments on YouTube that I am such a terrible tester, but you know, it's at least something.
Let's start somewhere. Yeah. It can always be improved later.
Yeah. Even though I also wonder what can be improved there, because you kind of, for instance, now, right, that's what I used as an example. As I do something strange here, it does fail. Good. So now that is doing the right thing and we know it. Okay. And now all the to-dos are done. We've written tests and would be in a situation where we can look back to the actual program. And by the look of it, the next thing is to tackle this manual creation of the tree ref iter and kind of get access to the breadth first reversal of any tree from that high level here. But that shall be done in the next episode.
Looking forward to it.
Cool, me too. Even though this is probably a bit of work, but now with the warm-up today, we can definitely do it. So thanks a lot. Thanks for watching and see you next time. Bye-bye.
Bye-bye.